Okay, so right now we're going to do half angle identities. So we'll start with sine x over 2 equals plus or minus the square root of 1 minus cosine x all over 2. Then cosine x over 2 is equal to plus or minus the square root of 1 plus cosine x all over 2. And then finally tangent. Oops. X over 2, which actually has two forms, 1 minus cosine x over sine x, or sine x over 1 plus cosine x. Okay, so the thing to remember about these, especially if you're using sine of x over 2 or cosine x over 2, is you have to be aware of where your angle lives. Okay, so sine of an angle is positive in quadrants 1 and 2, negative in quadrants 3 and 4. Cosine of an angle is positive in quadrant 1 and quadrant 4, and then negative in 2 and 3. Tangent of an angle is positive in quadrant 1 and quadrant 3, negative in quadrant 2 and quadrant 4. Okay, so it is very important that you know where your sign lives, because you do have to make a determination on whether or not you're going to use the positive version or the negative version of your radical. Okay, so we're going to do a couple of things with these. Okay, first we are going to find sine of an angle. Okay, and second, we're going to find the value of sine, cosine, or tangent, sometimes all three, given a ratio. And quadrant. Okay, and then third, we are going to do equations. Okay, so let's do our first task. Okay, so let's say we wanted to find cosine of 75 degrees. Okay, so we're going to rewrite that in terms of a half. So cosine is half of what? Cosine is half of 150. So 150 degrees divided by 2. Now we're going to look at where our angle is, 75 degrees is in quadrant 1. So cosine is positive. Okay, so now we look at our formula and we say, okay, well, since it's positive, 1 plus cosine x over 2, just like that. Now we start substituting positive. Okay, remember our x is 150 because x over 2 is 75. All right. So we either look on our unit circle or we remember that cosine of 150 is negative radical 3 over 2. Okay, so now we've evaluated everything. We have found, we've applied our formula. The rest is simplifying. Okay, this for a lot of folks is the hard part. Okay, so we're going to simplify the top first. And we get that 1 will turn into a 2 over 2 because we want that common denominator all over 2. Now we have that common denominator, so 2 minus rad 3 all over 2 divided by 2. Okay, now here's where things can get a little bit tricky depending on, how you do things. So what I like to do is I like to think of this as a divide sign right here. Then I'm going to invert and multiply. So I have 2 minus rad 3 times 1 all over 2 times 2. Which simplifies to that. And then very nicely, you get something that looks like this. Okay, notice that you have a radical inside a radical, which is fine. It looks a little strange, but that's what you do. Notice that most of the work is in the simplification. Okay, now let's try something in radian. Okay, let's try something a little bit tougher. Number 2. Let's go tangent 5 pi over 8. Okay, so let's see here. How could I write that as over 2? Well, what I could do is I'd say 5 pi over 4 divided by 2, right? Okay, so some of you might be raising your hand going, well, I don't really know how she got that. So what I do is I go x over 2 is equal to 5 pi over 8. I want to figure out who x is. So that's how I figure out who my x is that I divide by 2. Okay, now since this is cosine, you do have a choice in the matter. You also don't have to decide on your sign. Okay, so it just kind of depends on what you want to use. So I'm going to go for the cosine one on the top. Okay, let's see here. So I have 1 minus, okay, cosine of 5 pi over 4. That's going to be in quadrant 3. Let's see, so if it's quadrant 3, that means cosine will be negative. Okay, since we're in quadrant 3, that also means sine will be negative. Okay, now everything is substituted. Now it's simplifying. Okay, negative, negative, positive. Again, we have that complex fraction. Okay, we need to find the common denominator. 2 over 2 plus radical 2 over 2. That. All right, so now we have something that looks like this. Lots of 2's. And then we can start simplifying. So we can invert and multiply. That. Okay, so now we're like, okay, we've done a ton of simplifying. Are we done? And the answer is no, technically we're not, because we still have to rationalize the denominator. So I'm going to multiply by negative radical 2 over negative radical 2. And we're going to get negative 2 rad 2 minus 2 rad 2 like that. And then positive radical 2 like that. And then eventually we arrive at that. Now, question, are we done? The answer is technically no, because we can reduce the fraction. So we can factor out a negative 2. Cancel or reduce. And my answer is this or this. Okay, so I want you to think about that problem for a bit. You spent most of your time simplifying, okay? And that is where the mistake is going to be made, okay? All right, so the next video we're going to do using the half angle identities with the ratios.